Alright, in this video we're going to be looking at an infinite series, and so this is going to be the last of the infinite series videos from section 5.2, and we're going to be looking at telescoping series. So we'll do an example of what a telescoping series is going to act like. So we're going to look at the sum n equals 1 to infinity of 1 over n minus 1 over n plus 1. So that's going to be equal to 1 over 1 minus 1 over 1 plus 1, so that's n equals 1, plus 1 over 2 minus 1 over 2 plus 1, so that's going to be when n is 2, plus 1 over 3 minus 1 over 3 plus 1, plus 1 over 4 minus 1 over 4 plus 1, and etc. So let's look at the partial sum s of n, which is going to be 1 over 1 minus 1 over 1 plus 1, plus 1 over 2 minus 1 over 2 plus 1, plus 1 over 3 minus 1 over 3 plus 1, plus 1 over 4 minus 1 over 4 plus 1, plus dot dot dot. Now, what I'm going to notice is I'm going to notice that a lot of terms are going to actually cancel out or absorb, and so you're going to have a telescoping effect. And so only the first term is going to remain, and so there's only one first term left, and then there's probably going to be a last term left. So we only have one first term, so I'm going to only write one term before the nth term, which would be the n minus 1 term. So in place of n, you're going to have n minus 1. In place of n, you're going to have n minus 1. Okay, so there's the nth term, n minus 1th term, and then the nth term. Okay, so if I notice only the very first term is left, I'm going to write out the nth minus 1 term and then the nth term at the very end. So this is going to be 1 minus 1 half plus 1 half minus 1 third plus 1 third minus 1 fourth plus 1 fourth minus 1 fifth plus dot 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 plus 1 over n minus 1 minus 1 over n plus 1 over n and minus 1 over n plus 1. And then we're going to start our telescoping effect. So the 1/2's absorb, and the 1/3's absorb, and the 1/4's absorb. 1/5 would absorb with the next part of the next term. 1 over n minus 1 would absorb with the previous term or part of the previous term. The 1 over n's absorb, and so we're left precisely with the very, very first term and the very, very last term. And so that is our partial sum formula. And so if this infinite series converges and has a sum, it's going to be equal to the limit of the partial sums. And so we conveniently have a partial sums formula. So the sum n equals 1 to infinity of 1 over n minus 1 over n plus 1 is equal to the limit as n goes to infinity of s of n, which is equal to the limit as n goes to infinity of 1 minus 1 over n plus 1, and that's going to be equal to 1. Okay. Alright, so we have that telescoping effect. It kind of collapses on itself, and we're only left with the very, very first term and very, very last term. It is possible that it's not the very, very first and very, very last term. There might be a couple of terms at the beginning and a couple of terms at the end that remain, and the rest telescopes and collapse on itself. Okay, so telescoping series. Is going to follow the pattern of B1 minus B2 plus B2 minus B3 plus dot 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 Bn minus 1 minus Bn plus Bn minus Bn plus 1. And so this is going to collapse down on itself when we look at the partial sums. So the partial sum s of n, b1 minus b sub n plus 1, okay, and so all the rest of it absorbs. Now the limit of the partial sum is going to be equal to the limit as n goes to infinity of b sub 1 minus b sub n plus 1. b sub 1 is a constant, so we can slide that out of the limit, and we have b1 minus the limit as n goes to infinity of b sub n plus 1, and we'll go ahead and call that the sum. Okay. Now, b1 could be a couple of terms, and likewise b sub n plus 1 could be a couple of terms. And so we kind of have the first a couple of terms at the beginning and a couple of terms at the end for our partial sum formula. And so in the next example here, we're going to see something that kind of behaves like this. So we're going to look at the sum n equals 1 to infinity of 1 over n minus 1 over n plus 2. And so what's going to happen here is it's going to take a little bit of time for this telescoping effect to appear. And we're going from n to n plus 2, so we have a difference of 2. And so I'm going to want to go 2 back from n. So I want to write the n minus 1 term and the n minus 2 term to kind of help with determining what's going to drop out. This is equal to 1 over 1 minus 1 over 1 plus 2 plus 1 over 2 plus 1 over 2 plus 2 plus 1 over 3 plus, minus 1 over 3 plus 2 plus dot dot dot. So 1 minus 1/3 plus 1/2 minus 1/4 plus 1/3 minus 1/5 plus etc. Now the only thing that you see absorbing is the 1/3. However, in the next, if we wrote out the next piece would be 1 over 4 minus 1 over 6. And the 1 over 4s would absorb, and then the 1 over 5 would absorb in the next part. Okay, and so we do see that telescoping effect. Okay, so our partial sum S of n is going to be 1 minus 1/3 plus 1/2 minus 1/4 plus 1/3 minus 1/5 plus dot dot dot. So we're going to write out the n minus 2 term. Okay, so 1 over n minus 2 minus 1 over n minus 2 plus 2. So you replace the n with n minus 2 plus the n minus 1 term. So 1 over n minus 1 minus 1 over n minus 1 plus 2. And then the nth term plus 1 over n minus 1 over n plus 2. Okay. All right. So this is going to be equal to 1 minus 1/3 plus 1/2 minus 1/4 plus 1/3 minus 1/5 plus dot 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 1 over n minus 2 minus 1 over n. And so notice the 1 over n and the 1 over n there, so you had to go back 2 terms to see that it cancels. Okay, and then 1 over n minus 1 minus 1 over n plus 1 plus 1 over n and minus 1 over n plus 2. All right, and now we're going to go ahead and see what absorbs. So we got 1 and we got the 1/2. Okay, the 1/3 is going to absorb with the 1/3. The 1/4 would absorb, if I wrote out a few more terms, the 1/4 up here. So that would be appearing further along the series. The 1/5 would absorb with the 1/5 if I wrote up here, and that's going to appear further along in the series. Okay, so it looks like 1 and 1/2 survived the beginning. Now we're going to look at what happens at the end. Okay, so we saw the 1 over n's canceled. Now the 1 over n minus 2 would cancel with something previous. Likewise, the 1 over n minus 1 would cancel out with something previous. And so the last two terms, or the last two terms of the sequence, I suppose. This is the ace of n minus 1 and an ace of n. Their second term, the subtracting, is what's left over. So we're going to go ahead and include those two. So minus 1 over n plus 1 and minus 1 over n plus 2. So the sum n equals 1 to infinity of 1 over n minus 1 over n plus 1 is equal to the limit as n goes to infinity of partial sum S of n, which is equal to the limit as n goes to infinity of 1 plus 1/2 minus 1 over n plus 1 and minus 1 over n plus 2. So as n goes to infinity, both 1 over n plus 1 and 1 over n plus 2 are going to go to 0, so we get 1 plus 1/2, and so the sum of this series is going to be 3 over 2. Okay. All right, so let's look at a couple of properties. So the sum n equals 0 to infinity of ace of n, let's go ahead and suppose that that is a convergent series, and the sum is an, and we have a non-zero constant c, and the sum n equals 0 to infinity of c times a sub n. That series is just going to be the constant c times the sum of the series a. For example, if we look at the sum n equals 0 to infinity of 1 over 2 to the n, previously we showed that that is a convergent series with a sum of 2. So let's say we look at the series n equals 0 to infinity of 3 times 1 over 2 to the n. Well, it's going to be the constant 3 times the sum of the series, which is 2, and so that's going to be 6. Alright, now let's suppose that we are also given the sum n equals 0 to infinity of b sub n is equal to b. Then the sum n equals 0 to infinity of a sub n plus or minus b sub n is going to be the sum or the difference of their respective sums there. Okay, and this property would hold if all the series were starting at 1 or 2 or whatever we're starting them at. Okay, and on the next slide we'll do an illustration of this property sum equals 0 to infinity of a sub n plus or minus b sub n. So let's look at the sum n equals 0 to infinity of 3 to the n minus 4 to the n divided by 5 to the n. We can rewrite this as the sum n equals 0 to infinity of 3 to the n divided by 5 to the n minus 4 to the n over 5 to the n. Using properties of exponents, we can rewrite that as 3/5 to the n minus 4/5 to the n. Okay, now that's two geometric series. The sum n equals 0 to infinity of 3/5 to the n is going to converge to 1 over 1 minus 3/5, which is going to be 1 over 2/5, which is 5 over 2. The sum n equals 0 to infinity of 4/5 to the nth power is going to converge to 1 over 1 minus 4/5, or 1 over 1/5, or 5. Okay, so we have an a sub n and a b sub n. Their respective summations are 5/2 and 5, and then here we're taking the difference of them. Okay, so this is simply going to be 5/2 minus 5, or negative 5/2 is the sum of this series. Okay. Alright, so I believe we have one more example for the infinite series here, this telescoping series examples. So we're going to look at the sum n equals 1 to infinity of 1 over 2 to the n plus 1 times 1 over 2 to the n plus 3. Okay. So right now we don't have a lot to work with. We have literally geometric series and telescoping series. Since this is the telescoping series video, maybe it's a telescoping series. Later on we'll have some other tests that can tell us the convergence or divergence of this series. So we're going to use something we're familiar with. We're going to use partial fraction decomposition. Okay, so we're going to write 1 over 2n plus 1 times 2n plus 3 as a over 2n plus 1 plus b over 2n plus 3. We're going to go ahead and clear the fraction and multiply by 2n plus 1 times 2n plus 3. 1 is equal to a times 2n plus 3 plus b times 2n plus 1. So 1 is equal to 2an plus 3a plus 2bn plus b. Okay, now the n is kind of like your linear, so we're going to set the linear coefficients equal to each other. On the left-hand side, there are no linear coefficients, so it's going to be 0. So 0 is going to be equal to 2a plus 2b. This will give us the relation that a is equal to negative b. Now let's do the constants. So the constant of 1 is equal to 3a plus b. Now we know that a is equal to negative b, so 1 is equal to 3 times negative b plus b. So 1 is equal to negative 3, is equal to negative 2b, so b is equal to negative 1/2. And a is equal to negative b, so negative 1/2 would be positive 1/2 for the a. Alright, so now we've decomposed our fraction, and so now this is the sum n equals 1 to infinity of 1 over 2 times the quantity 1 over 2n plus 1 minus 1 over 2n plus 3. Okay, whoops. Well, I'm just going to rewrite it here, so we're just going to jump on to the next slide. So just rewrite what we just had there. It looks like the n equals 1 failed to copy over, so let's go ahead and put that in. Okay. Now we're going to go ahead and write out s of n, see if we can come up with a formula for s of n, and we'll take the limit of that. Okay, so we're going to plug in 1. Then we're going to plug in 2. And then I'm just down here. I'm going to write down what I got so I can kind of see what's happening. So this is going to be 1/2 times 1/3 minus 1/5 plus 1/5 minus 1/7. And okay, so they're canceling out almost immediately. So only the first term is going to remain. So only the first term is going to remain, and then also at the very end, the very last term is going to remain. And so, because I see only the first term here, that's not going to cancel out. I'm going to only dial it back to n minus 1 to help with seeing what all is going to absorb. All right, so we're going to write out for n equals 3. Okay, and then we just notice more of that nice pattern of stuff absorbing. Okay, and then we'll go out to, we're just going to go to the n minus 1. So where you see an n, put an n minus 1. Okay, and so that's going to simplify to 2n minus 1 minus 2n plus 1. And then the nth term. Okay, and then we'll start canceling. So the 1/5 absorb, and the 1/7 absorb. 1/9 would absorb with the next term. 1 over 2n minus 1 would absorb with the previous term. 1 over 2n plus 1's absorb. And let's fix our syntax error right here. All right, and so we got 1/2 times 1/3 minus 1 over 2n plus 3. That's what it ended up simplifying down to. So the sum, so this is an equal, the sum, n equals 1 to infinity, of 1 over 2n plus 1 times 2n plus 3 is equal to the limit of the partial sum, Sn, which is equal to the limit as n goes to infinity of 1/2 times 1/3 minus 1 over 2n plus 3. The 1 over 2n plus 3, it's going to go to 0 as n goes to infinity. And so this series is going to converge to 1/2 times 1/3 minus 0, or 1/6. And so that is the sum of this series. Okay, so both the geometric series test and the telescoping series will actually show us what the actual summation converges to. Later on, we'll get some more series tests, and they may not necessarily tell us what the series converges to, but they'll tell us whether it converges or diverges. All right, so stick tuned to the next video, and we'll be looking at the P series and the integral tests. So we'll see you next time.